Okay, today I'm going to cover one example from the freeway multi-lane highways, the multi-lane highways, and then I will cover the part about two-lane highways. Okay, so we have already covered some of the examples related to design and operational analysis. Today I will show you the example which is related to the growth rate, use of the growth rate. So we have a freeway, 6-lane freeway, trucks are given, terrain is given, free flow speed is given. They are saying no adjustments are required because we have standard conditions, peak hour factor is given, and the current traffic volume is given. Okay, and the traffic volume grows 6% every year. Okay, and for the next 20 years, the growth rate will remain the same. Okay, so for every year 6% it will increase. So we have to find out the level of service at this volume, and then we have to find out after 5 years, 10 years, 15 years, and 20 years as well. Okay, so first of all, whenever you have a growth rate problem, you will use this equation to calculate the future volumes. Okay, so Fn is your future volume after n number of years, P is your current volume, I is your growth rate, and n is the number of years you have. So if you want to calculate after 5 years, you will put your current volume here, the growth rate will go here, and the number of years will go here. So after 5 years, I will have this much volume. Okay, don't make the mistake of multiplying the growth rate with number of years and then multiplying with the actual value. Okay, it's not a simple addition. Okay, this is called as compounding growth rate, which means that every year you are multiplying with a new value. Okay, so 6% multiply by 6% at year 1 with 3,600. Year 2 it will not be 3,600, it will be 3,600 multiplied by 6% plus the actual value. Okay, so year 1, at the end of year 1 I will have this much value. Okay, so I have to use this value. Okay, I have to use this value for year 2. Okay, I cannot use 3,600. That's why the multiplication will not work. Okay, so what I have done here, I have used this equation to calculate how much volume I'm going to have after 5, 10, 15 and 20 years. Okay, now you have one volume and you have 4 more values here. Okay, you know how to calculate level of service from the previous examples. Okay, do it using each of these volumes, take it as your practice. Okay, I will use another method to do it. This method only works if you have the speed flow curve ready. Okay, this method only works if you have the speed flow curve ready. In the last example, in the last lecture, the last example which we did, I told you how to make the speed flow curve. So you can use the same procedure to calculate to make the speed flow curve, and then you can use the procedure which I'm about to tell you. Otherwise it will not work. So why I'm doing it now at this example, because they gave me free flow speed of 65. For a free flow speed of 65, the curves are available in the book. For a free flow speed of 65, the curves are available in the book. You can see it here. The curve of 65 is already plotted. For this curve, they already gave me the service flow rates. What is service flow rate? The maximum value at a particular level of service. So at level of service A, the maximum value is 710. Level of service B, the maximum value is 1170. And all these values are in passenger cars per hour per lane. Okay, all these values are in passenger cars per hour per lane. Okay, now what I need to do is I need to convert these values from passenger cars per hour per lane flow rate to volume. From passenger cars per hour per lane flow rate to volume, because the values which I have in my question are volumes and they are in vehicles per hour. They are not in passenger cars per hour. Okay, so I go here. First thing I do is I convert these values to vehicles per hour per lane. Okay, so okay, now you can see it. Okay, so these are the values, as you can see here at 65. These are the values. So I have 6-lane freeway. Each lane has each direction has 3 lanes. Each direction has 3 lanes. Okay, so first thing I will do is and multiply each of them with 3. Multiply each of them with 3. So the per lane item will go. Okay, per lane item is gone. So they are only passenger cars per hour now. Then I will multiply them with peak hour factor. Okay, up till here they were flow rates. When I multiply with the peak hour factor is given in the question, they became volume. When I multiply with them flow rate, with the peak hour factor, they become volume. So all of them are now volumes. Okay, but they are still passenger cars. My volume is in vehicles per hour, so I need to divide them by the factor of heavy vehicles. Okay, what is the factor of heavy vehicles? I will show you the equation once again from here. Factor for heavy vehicles. This is the equation. You have to put the percentage of trucks here and you have to put the equivalency factor here. Equivalency factor depends upon terrain. You can use this table or one of these big tables. In the question they said the terrain is rolling. Terrain is rolling. So the factor is 3. So I put 3 here and I will have 10% trucks. It's given in the question. 10% trucks is given in the question. So I will use this. I'll come here. You can see 10% trucks here, 0.1 and factor of 3. Okay. So this whole thing is factor for heavy vehicles multiplied with the volume in passenger cars. So factor of heavy vehicles multiplied by the volume in passenger cars. This gives you volume in vehicles per hour. Okay, this is volume in vehicles per hour. So now I know if I have to have level of service A, I can only have volume up to this much. For level of service B, this much. For C, this much. For D, this much. So I know the maximum values now. Okay, so now my work becomes very simple. I'll go here and I'll look at the values I already got. Okay, so now you can see here at air 0, which is the current air, the volume is 3600. If I look here, 3600 comes in this range. So B is already crossed and I can only have level of service C. So at air 0 with this much volume, my level of service is C. Then at air 5, my volume is 4800 something. So C is not possible. D is also less than 4800. So I can only have E. So at air 5, the volume is 4800, which can only be level of service E because D is already crossed. At air 10, the volume is 6400. You can see I have crossed E as well. So after E, I'm only in level of service F. So that's why the remaining airs, all of them have level of service F. Okay, so the logic is when you have crossed E, you can only have level of service F. And since the traffic keeps on increasing, level of service will remain F. Okay, now level of service F did not become F in air 10 because in air 10 it is 6400. It becomes F when you cross 5400. It becomes F when you cross this value, the capacity value, the level of service E value. So in which air did I exactly cross this value? So I'll go here. Okay, now remember this is my growth rate equation, this one. Okay, so I put the future value here, or I need the future value of this much, 5400 something. Okay, so I put future value as the maximum of E. Present value 3600. Growth rate 6%. Number of years we don't know. This is what I want to calculate. Okay, so if I try to calculate number of years from here, you can try it in the calculator. It will be almost 6.99 something years. So at the end of 7th year, you reach level of service F, meaning you cross this value at the end of 7th year. How am I getting this? From this equation. Okay, from this equation, the growth rate equation. The future value is the maximum of E, present is present, growth rate 6%, and is what we are trying to find out. So this is how we do this. Now there's a graphical method as well. You can use this graphical method. So in the graphical method, you plot capacity, which is the maximum of E. Maximum of E is capacity, and you plot these volumes. these volumes. Okay, so at 0 you will plot this one, at 5 you will plot this, this is at 10, and so on and so forth. When volume goes above capacity, this is your point, the air in which you reach capacity. So you can see it's somewhere here. If you draw the diagonal here, it will be almost air 7. Okay, so that you can use the graphical method as well. Now the authorities, when they know that after 6-7 years the highway is going to be a level of service F, they need to think about how to avoid it. Okay, how to improve the level of service F. So these are some things which you can do to avoid the level of service F. You can control the development in the area, control high-rise buildings, control the commercial buildings, and so on and so forth. This is called as zoning control. So you can control the traffic coming to this area. Another thing which you can do is increase public transport, provide better buses, more routes, and so on and so forth. So people will not use cars, they will use buses, traffic will be less. You can use alternate highways. You can improve or build alternate highways between 2 points. If you have more highways, traffic will be divided. And another thing which you can do is you can use staggered working hours, which they use for schools and offices and diplomatic areas. So they say, okay, school opening time will be different for different schools or different grades, and office opening time and closing time will be different as well. So all of them are not going to the area at the same time. So it is called as staggered working hours. If you need more examples, you need to look into these questions from these chapters of the old and the new edition of the book. Now I'll move on to the next one, which is the two-lane highways. It's a continuation of the same topic, level of service and capacity. So two-lane means one lane each direction. Okay, so they are very important and very risky because of passing. So on two-lane highways, passing is difficult because you have to go in the other direction. When you go in the other direction, you have a risk of hitting the car from the other side, and you have a risk of hitting the car on your side as well when you try to get back in your lane. So there are 3 people who can hit each other because of one passing maneuver, and the other lane is very close to you. So so according to human psychology, driver psychology, the traffic in one direction can affect the other direction as well. Okay, but in highways and freeways have more lanes, so your attention is not at the other direction, your focus is not the other direction. But in this case, it can affect your thinking process. Okay, this is a fact which I found in different studies. So in some cases, you may not have enough sight distance for passing. You have studied sight distance of passing in the highway engineering course. So if you don't have that much sight distance, required sight distance, you can make it the segment passing constrained. So passing is not allowed in that case. Passing constrained means passing not allowed. Other things you can do is you may have a temporary third lane. You may have a temporary third lane. So passing will be done from that third lane. If you are having a steep gradient, you may provide an extra lane for trucks only. We call it truck climbing lane. A truck climbing lane is provided on a steep gradient for trucks only. So trucks go to the extra lane while they are climbing on the gradient, so other traffic can move faster. Then you can have a temporary extra lane for turning movements. You want to pull out, go out, pull out, go out of the highway. So there's a short lane for you. You go into that lane and then you make the turn because you will be slower. Same thing if somebody is entering the highway from a street. So there will be a short lane for them. They will enter into that lane and then come to the highway to control their speed. Okay, to avoid risk of slow drivers on the highway direct. Okay, so this is called as turnout. So turnout is when you're coming in, pull out is when you're going out. In some very special cases, you can have a 2+1 highway. Okay, a 2+1 highway. So in 2+1 highway, the third lane is continuous. It's not temporary, it is continuous. But it's a very special case. Okay, the ideal conditions, the base conditions. Base meaning ideal conditions for two-lane highways include lane width of 12 feet, shoulder width of 6 feet, traffic only passenger cars, level terrain, no curvature, and no signals, no interruptions, and good environmental conditions. All of them are considered as ideal conditions. When these conditions are there, the traffic will be faster and your level of service will be better. Some examples, and you can see where the two-lane highways can be used. The cases I mentioned here, you can use them intercity, intracity, going for a picnic area, and so on and so forth. We have three types of segments according to highway capacity manual for two-lane highways. These are passing constrained, meaning two-lane passing not allowed. Two-lane passing not allowed. Then we have passing zone, meaning two-lane passing allowed. Passing zone is two-lane passing allowed. Then we have climbing and passing lane, which means an extra lane for passing. Okay, passing is allowed from the extra lane. Passing is allowed from the extra lane. So two lane, no passing, two lane, passing zone, and then we have passing from the extra lane, temporary extra lane, not 2+1, temporary extra lane. Okay, we discussed access points for multi-lane highways as well. These are unsignalized right-hand entry and exit. Unsignalized right-hand entry and exit. So there is no left turning here. These are called as access points. So that, like we did for multi-lane highways, you count how many access points you have on your segment, divide by the length. Number of access points, divide by the length. This is what you need in the analysis. If your two-lane highway has a median barrier, if the two-lane highway has a median barrier, then you will only count access points which are situated on the right-hand side. If it doesn't have a barrier, you will count access points from both sides. With barrier, only one side. Without barrier, access point counted from both sides. In any case, number of access points divided by the length of the segment. Okay, performance measures which we use for level of service. We need free flow speed, which is the best speed you have. Then we have average speed, which is the speed in the current conditions. Then we have percent followers and follower density. Percent follower means people who are following each other. Out of the total traffic, how many people or what percentage of people are following each other? Following means what? That they are very close to each other, so they are affecting each other. One slows down, the other one has to slow down. If he doesn't slow down, there will be a crash because they are very close to each other. So what is the threshold or limit for that? 2.5 seconds of headway. So any two drivers which are driving at a distance at an interval of 2.5 seconds or less, they are considered followers. They are followers. Okay. So out of 100, how many are having headway of 2.5 seconds or less? They are percent followers. Okay. So out of 100, the drivers which have headway of 2.5 seconds or less, these are percent followers. Then follower density is people who are following per mile. Number of cars which are following per mile. Density was cars per mile. Percent density is cars following per mile. Okay, this is the only difference here. Okay, this table shows you the maximum flow rate. Okay, from the table, the maximum flow rate for segments which have passing lane, and this value is for segments which don't have passing lane. So without passing lane, the maximum can be 1700. With passing lane, you can have one of these values. So you need the percentage of heavy vehicles, and you need to know the terrain type. This is called terrain class. 1, 2, 3, 4, 5 is called terrain class. For terrain class, we have another table. Okay. Now keep in mind, this procedure is taken for higher capacity manual, and we are only studying a very simplified short version of the complete procedure. For looking at the complete procedure, go to the end of the slide. You will find examples, page numbers, where you can find the complete problem done, and you will see there are lots of tables involved. There are lots of tables involved. So this is what we cannot cover in the class. Okay, level of service for two-lane highways. It can be for cars, it can be for bicycles, because two-lane highways can be used with bicycle lanes as well. For bicycle mode, level of service depends upon the opinion of the bicycle riders. So you go and ask the bicyclists, what is your opinion of the two-lane highway? And then you take the average and so on and so forth, and according to that you can have your level of service. But we are more interested here in the car version of the level of service. So for the car version, we have two categories now. Either your speed limit is 50 or more, or it is less than 50. If it is 50 or more, put your follower density here and see the level of service. If it is more than 50, put your follower density here and, sorry, if it is less than 50. If it is less than 50, put your follower density in this column and look at the level of service. This is data you need to calculate the level of service. Lane width, shoulder width, access point, speed limit, passing zone, vertical grade, horizontal curve, passing lane length if you have one, direction, volume in your direction, volume in the opposite direction, length of the analysis period. I mentioned it earlier as well with roundabouts. It's normally 15 minutes. 15 minutes. Peak hour factor, heavy vehicle percentage. And they have written how you can, from where you will get these values. So either you will get it from the field, you will get it from the design plans if it's a future highway, or you can calculate it from equations if it's future. Okay, and in some cases they have given the standard value as well. Okay, but there are some values which can only come from the field, like peak hour factor and percentage heavy vehicles. There is no calculation for that. This is the entire procedure of the highway capacity manual. I already mentioned it has 11 steps, and you can see there are iterations here. Okay, so this is how long it can be, and this is why we are not doing the whole thing in the class. Okay, according to vertical class type, terrain type, so terrain type for two-lane highway is slightly different. Okay, it's not the same as multi-lane highways and freeways. So you have to look at the number here. Okay, how to get the number? I will show you in the next slide. So this number, according to this number, the minimum and maximum length of the segment can be this much. The minimum maximum length. Passing constraint this much. So passing constraint again means 2-lane passing not allowed. Passing zone 2-lane passing allowed. Passing lane means passing allowed from the extra lane, temporary extra lane. So in each case, maximum and minimum length are given according to terrain type. How do I know the terrain type? From this table. Okay, this table gives you the terrain type. So 1, 2, 3, 4, 5. This is a terrain type. Okay, which is given in the table. What is this? The gradient. What is this? The length of the segment. Okay, so look at the gradient here, look at the length here, and decide the terrain class, the terrain type. Okay, there are two numbers here, outside the bracket, inside the bracket. Most of them are same. Very few of them are different. For example, this one, some of them are different. Very few. Okay, so if they are different, okay, then you have to look at your segment. So the number inside the bracket is for for passing which one? Let me check here. The number inside the bracket is for passing lane segment. Okay, so one of them is for passing lane segment, which is inside the bracket. So then you will see what your segment is and you will take the number. Okay, so inside the bracket is passing lane segment. Okay, for you need to calculate the flow rate for both directions of the road. You need to calculate the flow rate for both directions of the road. How to calculate the flow rate? Volume upon peak hour factor. Volume upon peak hour factor, which you can see over here. Then the next item is you need to calculate the free flow speed. Free flow speed can be measured on the road. You have done it for your term projects. I explained in the previous chapter as well. Or you can calculate it. The calculation for free flow speed are shown in this slide. So you need to first of all calculate base free flow speed. Base free flow speed, which is 1.14 into speed limit. SPL is speed limit. SPL is speed limit. After you calculate base free flow speed, the next equation gives you free flow speed. So you need the base value here. Then you need percentage of heavy vehicles, HV percentage. You need factor of lane and shoulder width, and you need factor of access point density. Factor for lane and shoulder width, this is the equation. Very simple equation. You need to put lane width here, shoulder width here. Then factor for access point density, this is the equation. Access point density, I told you, count access points divided by length, APD. Access points per length, APD, divide by 4. Okay, if the number is less than 10, take the number. If the number is more than 10, take 10. Minimum. Okay, so this ratio or 10, whichever is minimum. Then you have a factor here which they are calling as A. For A, you have this very big equation. Okay, so either A can be 0.0333 or A can be this whole thing. How do I get this whole thing? You have to put base free flow speed here, you have to put length here, you have to put V naught, which is the volume of the opposite direction. V naught is the volume of the opposite direction. So once you calculate this whole thing here, this big thing, you will check it with 0.033. If 0.033 is bigger, you will take this one, otherwise this one. Now in this equation you can see you have BFFS, L and V naught, but you have A naught, A1, A2, A3, A4, A5 as well. Okay, from where to get these factors? From this table, and this depends upon vertical class only. Okay, so whatever the vertical class is, I showed you, vertical class comes from here. So you take the vertical class from here, then you come to this table and find out what are your A values, and you put it here, compare it with 0.033. This is a summary of what I already mentioned to you. Once you have calculated the free flow speed, now you will calculate the average speed. Average speed can be equal to free flow, or it can be less than free flow. When it will be equal to free flow, if the volume in if the flow rate in your direction is less than 100. If the flow rate in your direction is less than 100, your average speed equals to free flow speed. If it is more than 100, then you need to use this equation. In this equation, you have M and P. This is where I have shortened the procedure. M and P has its own set of tables. So we are not looking at those tables. We will take M and P from me. Okay, I will give you M and P values. You want to see the tables, go to high capacity manual, have a look at it. Otherwise, in the exam, I will give you directly the values of M and P. M is called slope, P is called coefficient. Slope of speed, coefficient of speed. Once you have S value from here, you will calculate percent followers. Percent followers will use this equation. Again, you have VD, which is flow rate in your direction. Flow rate in your direction. And you have M and P. This is different than this one. So we have two M's and two P's. One set for speed, average speed, another set for percent followers. So I will, if this type of question comes, you will need two M's and two P's. One each for average speed and percent followers. Once you have calculated it, you will come here, you will calculate follower density. Okay, follower density is percent follower divided by 100 multiplied by flow rate in your direction divided by speed in your direction. Flow rate upon speed. Okay, once you have follower density, you have this table which tells you about the level of service. So follower density will be put here to calculate the level of service. Let us do a very small simple example. So the segment is given here, okay, and the segment we have the length is given, the type is given, no passing lanes, volume in one direction is given only. I'll tell you why later on. Peak hour factor, speed limit, percent heavy vehicles, gradient, curvature, no curvature, lane width, shoulder width, access points are given. Access points are 0. Okay, let us see what they are doing. First thing is you calculate flow rate in your direction. Okay, so volume divided by peak hour factor. Volume divided by peak hour factor. Okay, so this gives me flow rate. Next thing is base free flow speed. Base free flow speed is 1.14 into speed limit. Okay, so my speed limit is 50 multiplied by 1.14, which gives me 57. Okay, then I need to calculate these factors FLS, FA and A. So I come here. Now if you look at the equation for FLS, my lane width is 12. 12 minus 12, 0. My shoulder width is 6. 6 minus 6, 0. So this whole factor becomes 0. Okay, the whole factor becomes 0. My access points are 0. Access points are 0. So access point density will also be 0. Access point divided by length. 0 upon length, 0. So APD upon 4, if this one is 0, the ratio is 0. And you have to take the minimum. So 0 or 10, you will take 0 obviously. Minimum is 0. So FA is 0, this one is 0. The only thing remaining is A. Now A is either 0.0333 or this whole thing. I had to look at my vertical class now. The gradient is 0. The gradient is 0. Okay, I come here and look at the vertical class. When the gradient is 0, the vertical class is 1. When the gradient is 0, the vertical class is 1. Okay, so that means 1, this one. Okay, so you can see all A's are 0. Now you take these 0 values and put it in this equation. When you put in this equation, this whole big thing becomes 0. This whole big thing becomes 0. But I have to take what now? Maximum. I have to take maximum. So I'll take this one or 0. This one or 0. Maximum is 0.033. So A is 0.033. Okay. So I got BFFS. This one is 0.033. Percentage heavy vehicles are given. This is 0. This is 0. Okay. So free flow speed. Okay. This is my base free flow speed. This is my A value. This is my percentage of heavy vehicles and the factor for lane width and shoulder width and access points. Okay, so my speed is, sorry for that, I believe there's a mistake here, let me correct it, 56.83. Okay, so my free flow speed is this much. Okay, now I have to go here and see if free flow is average speed is free flow speed or this one. My flow is 800. My flow is 800. So I have to use this equation. To use this equation, I need M and P. M and P. So where is M and P? You have the values of M and P. Okay. So I will calculate my speed using this equation. Okay. This equation. This is my free flow speed, which I already calculated. This is my M value. This is my P value. Okay. So my speed comes out to be this one. Okay, why I'm using this scary equation? Because my flow rate is more than 100. Okay, so I calculate the speed here. Okay, then I will calculate percent followers. Percent followers has this equation. Okay, you can see M and P again. So what are these new M's and P's? You will take the second set from here. And here you can see M can be positive for one case and negative for the other case. So that's why you have to be careful. You cannot make them equal. You cannot make them round off or something. Okay, because it's completely different. So now in this equation, I will use the new M and P's. Okay, so this is what I have done here. Okay, you can see the equation over here. Okay, 100 is constant. This is the new M. This is the new P. And 800 is my flow rate. Okay, 1000 from the equation. And this is my percent followers. This is my percent followers. After you get the percent followers, you put over here, then VD upon S. You already calculated all these things. Percent followers divided by 100. This is my VD, this is my S speed. So you get the follower density 10.1. I'll go to the level of service table. Okay, my free flow is, my speed limit is 50. My speed limit is 50. So I look into this column. Okay, not this one. This one. Speed limit 50. My my follower density is 10. So I'm in this range. So my level of service is D. Okay, follower density was 10. Speed limit was 50. So level of service is D. Now this table gives you another criteria for this table gives you two criteria for level of service F. Now if you anything which is more than 12 and more than 15 is considered level of service E. Anything which is more than 12 for this speed limit and more than 15 for this speed limit is considered level of service E. But how do I know about level of service F? Level of service F, simple criteria, demand more than capacity. Whenever demand is more than capacity, level of service is F. Okay, how do I know demand is more than capacity? For example, in this case, my flow rate is 800. Flow rate in my direction is 800. I'll come to this table or this value and I will compare the flow rate with the value. Okay, 800, you can see 800, if it was a passing lane segment, the capacity is more than 800. Okay, so level of service is not F. If it was a passing constrained segment or a two-lane segment, not having an extra passing lane, I'll look at this number, which is 1700. Okay, so whenever my flow rate is less than these values, one of these values, either from the table or this number, then my level of service is not F. Okay, level of service, not F. So level of service F only comes from this criteria. If your flow rate is more than these values, one of these values, your level of service is F. No calculation required. No other calculation required. Okay, so for example, I calculate flow rate. It comes out to be 2000. 2000. Okay, so you can see 2000 is more than any of these values. So my level of service is F. Okay, let's say it was 1600 and it's a passing lane segment. For a passing lane segment, I will look into this table. Now 1600 is more than this table, right? Okay, any value in this table. For a passing lane segment, level of service is F. For a passing constraint section, okay, at 1600, I still don't have level of service F. I can go up to 1700. So if it was a passing constraint section or a 2-lane section, I'll continue with my calculation. Okay, but if it was a passing lane segment, I stop my calculation and write level of service F. So this is about this example. The procedure is written here, MNP values are given here. I will change them in the exam if the question comes. And these are the examples which are given in highway capacity manual. They are full examples with all the tables and all the complete procedure. You can have a look at it. So this is it for now, and see you next time, inshallah.